Let's go ahead and take a look at this particular problem then. So it says you are canoeing along 18 miles of river. You travel 3 miles per hour when paddling and 2 miles per hour when drifting. Write and graph an equation describing your possible paddling and drifting times for the trip. Give 3 possible combinations of paddling and drifting times. So here's one thing that as I walked around, I'm trying to make sure that we understand. I've got some students that are using their variables, and then they're talking about how many miles per hour they're traveling, okay? The number of miles per hour you're traveling in this problem does not change. It's not a variable. If I am paddling, how fast am I going? 3 miles per hour. If I'm drifting, how fast am I going? 2 miles per hour. Those don't change. What changes in this problem is what? How long you do those two things. Okay? So what we're looking for in this problem is our paddling time and our drifting time. Those need to be our two unknowns. All right? And again, when we do this, here's what I want you to be aware of. We may have two different looking graphs, but when we go to give our 3 possible combinations here, we should be talking about the same thing when we get done. Okay? So what your equation looks like and what your graph looks like is going to depend exclusively on what you define your variables as. All right? So maybe give me one thing that you would like to let the variable x represent. Okay, but 3 is a number. Needs to be some unknown quantity. We said we're looking for 2 things in this problem. What's one of the 2 things we're looking for? What's that? Okay, what about paddling? What do we not know about paddling in this problem? Because we already know how fast we're going. We already know that when I paddle, I'm traveling 3 miles per hour. So that's not my variable. What do I not know about paddling? Oh, hold on here, please. Any thoughts? What do we not know about paddling? Serena, what do we not know about paddling? The number of hours. Okay, so that's got to be my variable. So in this case, we're going to let x represent the number of hours paddling. Again, here's what I want you to be aware of. A variable is a quantity that can change. I could paddle for 0 hours, I could paddle for all of the hours. That variable can change. How fast I go when I'm paddling, that doesn't change. So my variable represents something that could change throughout the entire problem. Okay? Now, I have a second variable in this problem, and we're going to use the variable of y. All right, Kane, what's my second variable in this problem going to represent since we've already used number of hours paddling for x? Number of hours drifting. All right, so this is where we're going to begin. And again, how you define your variables is going to change what your equation looks like and what your graph looks like. Now, before I just write my equation in general, here is, we always talked about this even with story problems, like in your mind, think about what you're doing here. All right? So as we travel down this river, we're traveling one of 2 ways. We're either paddling or we're drifting. Okay? So what I need to be able to do is take the distance traveled by paddling. I need to take the distance traveled by drifting. And what am I going to do with those 2 total numbers? What's that? We need to add those 2 together. And when I add these 2 together, this is going to give me my total distance traveled. All right? So before I use any numbers, any variables, this is the relationship. As we are in this canoe, we are traveling when we paddle, we are traveling when we're drifting, and if I add those two together, that's going to tell me how far I've actually gone. So now my job is to come up with some way to show somebody how far I've traveled when I've been paddling. Well, if you want to know how far you've gone, or how far you've gone, you need to know two things. You need to know how fast you're going, and you need to know how long you're going. So when we paddle, how fast are we going? 3 miles an hour. According to my variables, how long am I doing that? I'm doing it for X hours. So if I'd like to figure out how far I'm going to take 3, which is the rate, how fast I'm going, and I'm multiplying this by X, which is how long I'm doing it. Chemical groups, right, are all familiar with the distance equals rate times time formula, right? Okay, how you figure out how far you've gone. This is exactly what we're using here. Okay? Now, what I need to do is I also need to add in how far I've gone when I've been drifting. So again, if I want to know how far I'm going, I need to know how fast I'm going and how long I'm doing it. So when we're drifting, how fast are we going? 2 miles an hour. According to how I've defined my variables, how long are we doing that? For y hours. So this is going to be 2 times y for this part here. And then if I add those two together, it's going to tell me how far I've gone. Well, at the end of this trip, how far have I gone?
18 miles.
A total of 18 miles. So there's my equation. 3x plus 2y is equal to 18. Does everybody see where we got that from? Okay. Now we need to be able to graph this. So if we're going to graph it, what we've been talking a lot about lately is graphing these by using intercepts. So let's go ahead and graph this by using our intercepts. First of all, by finding our x-intercept. So what do we do to find an x-intercept, Quentin? You must let your y value be equal to 0. So we're going to take 3 times x plus 2 times 0, and we're going to set this equal to 18, and we're going to go ahead and solve for what x needs to be equal to. Okay? So 3 times x plus 2 times 0 is 0 equals 18. And if I take 3x plus 0, that's going to give me 3x. So that tells me that 3x is equal to 18, and if I divide each side by 3, then x needs to be equal to 6. So here's what we know. Our x-intercept in this problem is 6. That's going to be part of how we graph this one. All right, Hayden, the next thing I need to find is my y-intercept. Hayden, remind us, how do we find a y-intercept? You let your x value become 0. So we're going to take 3 times 0 and add 2y, and this should be equal to 18. And then again, solve for y. 3 times 0 is 0, plus 2y equals 18. 0 plus 2y is 2y. So 2y equals 18. And if I divide each side here by 2, then y should be equal to 9. That tells me that our y-intercept is 9. Yep.
One of the things that comes a lot, people saying like y equals 9 and leaving it like that, that's not the same as saying the y-intercept is 9. So I'll make sure that I think that.
There we go. All right, so now we should be able to use these two and graph them. So my x-intercept, where does it cross the x-axis at? Right here, at 6. Okay, where does it cross the y-axis at? Right here, at 9. All right, we're going to go ahead and use our straight edge, which I gave all of you, to connect those 2 points. Am I going to use arrows on each side here? Nope. Because as soon as I start getting into this quadrant, this would represent a negative y value. You can't have a negative y value. Okay, as soon as I get into the second quadrant, that's going to represent a negative x value, and I can have a negative x value. Now, what it asked for was a total of 3 different combinations. So you've already got 2 of them right here, 1 and 2. This is the ordered pair 6, 0. This is the ordered pair 0, 9. Now, I picked this equation simply because you need to find at least a third, if you're going to already use those 2, And this has more than a third for you to pick from. So I just want to kind of show you that you could choose a couple of these different ones. You could choose this point right here, which is the ordered pair of 2, 6. Okay, you also could choose this ordered pair right here, which is the ordered pair of 4, 3. So I need you to give me 3 combinations. You got 4 to choose from. Now again, your equation, your graph may look different, and the only difference should be how we define our variables. When I go to explain this, this shouldn't be any different. So somebody tell me, what is 0, 9 going to be described as? Serena.
0 hours of paddling.
There you go. You could go 0 hours of paddling, and you could say 9 hours of drifting. All right, somebody tell me, what is the ordered pair 2, 6 going to represent? Go on.
2 hours of paddling and 6 hours.
There you go, 2 hours of paddling and 6 hours of drifting. 4, 3 is going to represent what? Use your variables. Come on, ladies and gentlemen. Miles.
4 hours of paddling and 3 hours.
There you go, and finally 6, 0 is going to represent? There you go, 6 hours of paddling and 0 hours of drifting. Okay, again, I don't want us to just be able to graph, especially within the story problem. I want us to be able to understand what we're showing here. Okay, now, here's one thing that I want to caution you about, and this came up with a couple of us. When you're finding points to describe, some of these are close to other points, but they're not exactly going through it, all right? So I had a student who said this, Mr. Tompkins, I'm going to use this point of 3, 5. Except here's the conversation that they had. 3, 5 doesn't work. And here's the thing, that shows me a higher level of understanding. How did they know 3, 5 didn't work? Because 3 hours of paddling would be 9 miles, 5 hours of drifting would be 10 miles, and 9 plus 10 is not 18. So they understand that that doesn't work because when they take that point and plug it in, they're not traveling a total distance of 18 miles. Okay? So again, we just had to go back and look at the graph and say, all right, is 3, 5 actually on the graph? And the answer to that problem is no. It's close, but it's not showing that somebody's traveling a total of 18 miles. So you need to make sure that when you draw your line, you are being very, very precise with how you draw them, and you're being very picky. You're not looking for something that's close to the line. You are looking for something that is exactly on the line.
And that's why I want to make sure we're using our straight edge.
Yep. I'll be honest, right now, in my Algebra 1 class, we are doing a system of equations. Okay, so what we're doing in Algebra 1 right now is this. Okay, and we're solving this. You're not ready for that yet, but this is what we're doing in Algebra 1. And I've got students that can't solve this correctly. And here's why they can't solve it correctly. They're not graphing correctly, and they're not precise. Well, I'm going to do this, and I'll just draw it, and yep, I'm going to do this, and all of a sudden they're like, my answer's not right. Well, no duh. Because when you don't pay attention to how you draw a graph, and you don't use your straight edge to graph it, don't expect this to turn out to be a nice neat number. And so today, I gave my students, they had 8 problems to do in 40 minutes. And I didn't have a single student get through 8 of them in 40 minutes. And almost all of them, we had to go back and we had to fix their graphs. They could tell me how to graph it using all of the shortcuts that we've learned in Algebra 1, but they're not using them correctly enough to actually use that to find an answer. So using the straight edge, and I'll be honest, like one kid, he refuses to sharpen his pencil. So his line is about that fat. Well, there's a big difference between 3, 5 being on this line and 3, 5 not being on that line. So all of those little things become big things when this becomes a multi-step idea. All right? You're about a third of the way being able to do that. But you've got to be able to graph a line not like kind of close. It's got to be 100% on for you to be able to solve a system of equations like that. Okay? All right. Well, let's go ahead and take a look at the homework assignment from last night, discuss any questions we've got. All right, I'm going to read through these pretty quick, and I'm going to show the graphs of these fairly quickly, so please follow along. Number 1, 2, and 3, here's something you need to be prepared for. Remember that if you give me an ordered pair to these problems, I'm telling it wrong on your assessments. The x-intercept should be the x-coordinate of the point of where it crosses the x-axis. The y-intercept should be the y-coordinate of the point where it crosses the y-axis. You are giving me a number, and that is it. So in number 1, my x-intercept is 2, and my y-intercept is 3. Okay. Number 2, your x-intercept is -4. Your y-intercept is 1. That's all you're listing. And number 3, your x-intercept is 0. Your y-intercept is 0. In problem number 4, this is just flipping it around. Now they're giving you these, asking you to graph it. And notice how they give them to you. They don't give them to you as ordered pairs. They tell you, here's the x-intercept, here's the y-intercept. So in problem number 4, we're going to put a point at 1 on the x-axis, a point at 4 on the y-axis. Those are my two intercepts. So for problem number 4, this is what your graph should end up looking like.
And if you don't have the arrows, what happens?
Then it is wrong. Okay, because remember, we're not talking about a story problem here where you can't have negative x's and y's. Everything in this problem works. Okay? In problem number 5, you've got an x-intercept of 5. That's going to be right here. And a y-intercept of -3, which is going to be right here. So now we grab the straight edge, we draw the line that goes between those. That's what we're looking for the answer to problem number 5. In number 6, you've got an x-intercept of -3 and a y-intercept of -2. So we're going to put a point at -3 on the x-axis, a point at -2 on the y-axis. That's what our graph should look like for problem number 6. And for problem number 7, we've got an x-intercept of -2, a y-intercept of 4. So our line for this one should look like this. All right, problem number 8. This should be familiar. It's almost identical to what we just got doing. Okay? So you are canoeing. Now in this particular problem, it is a 24-mile stretch. All right? Where you travel 6 miles per hour paddling and 2 miles per hour when you drift. So I'm going to do all of this, but I'm going to do it rather quickly here. We're going to let X represent number of hours paddling. We're going to let Y represent the number of hours drifting. So when I do that, my equation for my personal problem is going to be 6x plus 2y is equal to 24. The only way your variables should be flip-flopped is if you've chosen different ones. Now, I'm not going to go through all the work here unless we want to see it. We're going to get an x-intercept of 4 and a y-intercept of 12. What's this tell me I'm going to need to do to my graph? Set. Make it bigger, right? I'm going to have to change my scale. Because I can't go up to 12 on my y-intercept. So here's what I'm going to do. I'm going to go 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. We talked about that last week, right? I don't need to change my x-axis because I'm just going to 4. So I'm going to put a point right here at 4, and then a point here at 12, which for my graph is only 6 units up. Now, the biggest thing for me is to understand how that changes my 3 possible answers. Okay? This is 0, 12, and this still doesn't work. Okay? This is 0, 12. This is 4, 0. Okay, begin with that. What does this mean? 4, 0. Chloe, what's 4, 0 mean in my problem with my variables? 4 hours of paddling and what? 0 hours of drifting. Rollin, what's 0, 12 tell me?
0 hours of paddling and 12 hours of drifting.
There we go. All right, and then finally, here's my question. What's that ordered pair? It's 2, 6. Now, this is where you got to pay attention to how you change your scale. Some people would be like, that's 2, 3. Nope, because on my y-axis, I let each one of those count as a 2. 2, 3. All right? Jacinthia, sorry, 2, 6. Jacinthia, what's 2, 6 represent for us? There you go. And again, when we plug that into our equations, that should give us our total of 24 miles that we're traveling. All right, problem number 9. It says that a fitness center charges 25 cents or $25 for a yoga class and $45 for an aerobics. The fitness center receives a total of $675 for the 2 classes. Write and solve an equation to represent this. So, in this particular problem, here's how I'm going to define my variables. We're going to let X represent the number of yoga classes, and we're going to let Y represent the number of aerobic classes. So when I go to use my equation here, we're going to have 25x plus 45y is equal to our total of $675. Okay, because that's how much money we made total. So now we need to find our 2 intercepts. Is that 27? Yes?
That's 27.
27?
15.
15? Thank you. There's my 2 intercepts. So notice what I'm going to have to do is we're going to have to change them both. So if I want to go up to 27 here, really it means I need to at least get to 27 or 30. So what should I choose as my x-axis? Go by 3s. Okay? 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. Okay, this has to go up to 15, which means I could go by 2s, except then I'm stuck halfway in the middle, aren't I? So I'm going to do the same thing here. I'm going to go 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. So now when I go to draw the graph of this one, my x-intercept is at 27, 0. Somebody tell me what's 27, 0 mean? Come on. 27 classes of yoga and 0 aerobic classes. Okay, somebody tell me what 0, 15 represent, Miles?
15 classes of aerobics, 2 classes of yoga.
There you go, 15 classes that are aerobic and 0 classes that are yoga. And then to find my third one, we're going to need to take those and join them together. and then find a point that happens to be on my line. Did anyone find one? But look at your graph, right? You should have to look up here. $24. Oh, but it's 27.0.
Over a big swing.
Okay, 15.6. Does 15.6 work? You might say, well, is this on there? Here's my question. It goes back to the one I talked about earlier. Would 15.6 work? Grab your calculators. 25 times 16 is 400. 6 times 45 is 270. That's not going to give me 675. What's that?
705.
Yeah, it's not going to work. So do you see how you can check to see what is on your line? You should be able to, if I'm like, well, I think this point is on here, okay? You should be able to plug it in here and see if that combination actually works. And if it doesn't, then that combination is not on your line. Remember, that's what it means to be on a line, is it is an ordered pair that when you plug it into the equation, is actually going to make your equation true. If you're plugging in a point and it's not making your equation true, something is not solved correctly. All right, we'll take a look at 10 through 19 at the beginning of 7th period, and then take our assessment.